Hello all, welcome to the video tutorial on embedded systems. Today I will be discussing about trends in embedded industry on module 6. We will cover these points through this video: introduction, processor trends, embedded OS trends, development language trends, open standards, frameworks and alliances, bottlenecks, previous year questions. Introduction. An embedded system is an application-specific system designed with combination of hardware and software to meet real-time constraints. The key characteristics are speed, security, size, and power. The major trends in embedded systems revolve around the improvement of these characteristics. There are 5 main trends in embedded system. In this lecture, I will be discussing about each of these trends in detail. The first trend is processor trends. The processor technology is a prime driving factor in embedded development area. That means processor technology, it drives or it controls the embedded development area. There are 8-bit, 16-bit and 32-bit processor designs. Even though there are 16-bit or 32-bit processor designs, we widely use 8-bit processors in low-end application as it is cost-effective. Today's 8-bit processors are power and feature-packed. They are an integrating multiple of IC functionalities into a single chip. This concept of integration, it leads to miniaturization and cost saving. Miniaturization means we are reducing or decreasing the size of the components and thus we can save this cost. In earlier days, it was procedural execution and later then it came single stage instruction pipelining and then 8-stage pipelining. Today, processor families like ARM are supporting 8-stage pipelining with instruction and data caching. The operating clock frequency was a bottleneck in processor designs. Due to the advancement of processor technology, the clock frequency can be increased and the processes can be done in a fast manner. Multiprocessors are also used in this case. The first processor trend is System on Chip or SoC. It makes a system on a single chip. It integrates all function systems required to build an embedded product into a single chip. SoC are used in set-top boxes, media players, PDA, etc. SoC integrate multiple functional components on the same chip. It can save space and also miniaturize the overall system design. The second processor trend is multicore processors or chip-level multiprocessor, CMP. This concept employs multiple cores on the same processor chip, operating at the same clock frequency and battery. Based on number of cores, processors are known as dual-core, tri-core and quad-core. Dual-core consists of 2 cores, tri-core 3 cores, quad-core consists of 4 cores. These processors implement multiprocessing concept where each core implements pipelining and multithreading. The third processor trend is reconfigurable processors. It is a processor with reconfigurable hardware features. They are same like processors, but they have an extra memory to change the hardware features. Reconfigurable processors can change their functionality to adapt to the new requirement. For example, in case of a camera, it can be configured as heart of the camera or that of a media player. The microprocessor along with the PE, that is array of programming elements. The PE can be used as a computational engine like ALU or memory element. The second trend is embedded OS trends. The advancement of processor technologies have caused a major change in embedded OS industry. A lots of options like either it can be commercial or open source. Virtualization concept, it replaces monolithic architecture with microkernel architecture. This enables only essential services to be contained in the kernel and rest are installed as services in user's space as it is done in case of mobile phones. Off-the-shelf OS are now becoming a major trend. The third trend is development language trends. There are two aspects, embedded firmware and embedded software. Embedded firmware. It is an application that is responsible for execution of embedded system. It is a software that performs low-level hardware interaction, memory management, etc. Embedded software. It is the software that runs on host computer. It is responsible for interfacing with the embedded system. It is a user application that executes on top of the embedded system on a host computer. Earlier, languages were limited to C and C++, but now languages like Microsoft C Sharp, ASP.NET, VB, Java, etc. are also available. The first development language trend is Java for embedded development. Java is not a popular language due to its nature of execution. Java programs are compiled into bytecode by a compiler. This bytecode is then converted into processor-specific object code with the help of JVM. During runtime, this interpretation of the bytecode by JVM makes Java applications slower than other cross-compiled applications. This disadvantage is overcome by providing inbuilt hardware support for Java bytecode execution. Next, we can see a figure of Java-based embedded application development. On top, we have Java application, then JVM, then embedded OS, and then finally embedded hardware. Another technique used to speed up execution of Java bytecode is by using JIT compiler or just-in-time compiler. It speeds up program execution by catching all previous executed instructions. Following are some of the disadvantages of Java in embedded system development. First one, the interpreted version of Java is slower and is not meeting the real-time requirement. Second, garbage collector of Java is non-deterministic. Third, those processors that don't have JVM require it to be ported for specific processor architecture. Fourth, Java is limited in terms of low-level hardware handling compared to languages like C and C++. Fifth, runtime memory requirement of Java is high, which is not affordable by embedded systems. The second trend under development language trend is NetCF for embedded development. It stands for .NET Compact Framework. .NET CF is a replacement of original .NET Framework. The CF version contains all necessary components for application development. The original version of .NET Framework is very large and is not a good choice. The .NET Framework is a collection of precompiled libraries. CLR or Common Language Runtime is a runtime environment of .NET. It provides functions like memory management, exception handling, etc. Applications written in .NET are compiled to a platform-neutral language called CIL or Common Intermediate Language. For execution, CIL is converted to target-specific machine instructions by CLR. Next, we can see the figure of .NET-based embedded application development. On top, we have .NET languages, then we have compiler, then we have CIL, and at last we have CLR. The fourth trend is open standards, frameworks, and alliances. It is of four types: OMA, OHA, Android, and OpenMoko. First one is OMA or Open Mobile Alliance. It is a standard body for creating open standards for mobile industry. It was formed in June 2002 by the world's leading mobile operators, device and network suppliers, information technology companies, and content and service providers. OMA delivers open specifications for creating interoperable services that work across all geographical boundaries on any bearer network. The second one is OHA, that is Open Handset Alliance. It is a business alliance formed by various handset manufacturers, chip manufacturers, platform providers, and carriers for developing standards for mobile devices. The third one is Android. It is an open source platform and operating system for mobile devices. It was developed by Google Corporation and retained by Open Handset Alliance or OHA. Android is an operating system based on Linux kernel. The fourth one is OpenMoko. It is a project to create a family of open source mobile phones, including the hardware specification and operating system. The first subproject is OpenMoko Linux. It is an operating system designed for mobile phones built using free software. The second subproject is developing hardware devices on which OpenMoko Linux runs. The fifth trend is bottlenecks. It is of three types. First one, memory performance. The rate at which processors can process may have increased, but rate at which memory speed is increasing is slower. Second one, lack of standards or conference of standards. Standards are followed only in certain handful areas like mobile handsets. In other areas, there is a growing trend of proprietary architecture and design. Third one, lack of skilled resources. There is a lack of availability of skilled laborers. There may be thousands of developers who know how to code in languages like C, C++, Java or .NET, but a very few in embedded software. Previous year university questions. Explain System on Chip Technique, SoC, May 2019. SoC makes a system on a single chip. It integrates almost all functional systems required to build an embedded product into a single chip. SoC are used in set-top boxes, media players, PDA, etc. SoC integrate multiple functional components on the same chip, thereby saving space and miniaturize overall system design. Next question is, write any four bottlenecks available in embedded industry, May 2019. Memory performance, lack of standards or conference of standards, lack of skilled resources, lack of employees. Next, we will be discussing the video summary. There are 5 main trends in embedded system. They are, first one is processor trends. It is of 3 types: system on chip, multi-core processors or chip-level multiprocessor, reconfigurable processors. Second trend is embedded OS trends. Third trend is development language trends. It is of 2 types: Java for embedded development, NetCF for embedded development. Fourth trend is open standards, frameworks and alliances. It is of 4: OMA, OHA, Android and OpenMoko. And the fifth and last trend is bottlenecks. It is of 3: memory performance, lack of standards or conference of standards, lack of skilled resources. And by this, it is the end of this lecture. Thank you.